9.1, number 22, find the values of x for which the geometric series converges. Find the function of x it represents. So our initial term, if I plug 0 in, is going to be 1 over 1 minus or r. So it's tangent of x to the nth power. So that's what I'm multiplying by every single time. So that's my r. So it becomes 1 over 1 minus tangent x. So that's the summation of an infinite geometric series, and it'll converge only if our r is between -1 and 1. So if I had thought of tangent, where's tangent 1, and where's it -1, it'd be right here. So anywhere between -1 and 1, any of these will produce a convergent series as long as our x is between -pi/4 and pi/4. So that's the first kind of region that will produce a convergent series. Now it happens again as we add pi to it. So if it was between 3pi/4 and 5pi/4, tangent would be between -1, well, between -1 and 1. Remember, tangent is kind of slope. Tangent, same thing as slope, between the slope of -1 to 1 and between -1 to 1. So it's going to keep creating these boundaries every pi. So if I had that x value, it would, if I add pi to it, it would be right over here. So to represent this repeating every pi, you could just say x has to be -pi/4 and pi/4 in order for it to happen every pi, so that you could just say -pi/4 plus pi n and pi/4 plus pi n. So that, where n is an integer, should get everything. So if n is 0, then we're between -pi/4 and pi/4. If n is 1, now we're between 3pi/4 and 5pi/4. If n is 2, then we're right back over here, and so on. So that would be our answer. As long as x is between this and this, it would converge.